Okay, let's say we're going to talk about now absolute value inequalities. It works. Oh no. So let's say I have the absolute value of x is less than 4. Let's think about this for a minute. So we need to be less than 4. So obviously, the obvious solution for x would be numbers that are less than 4, right? So I'm thinking, yeah, 3, 2, 1, 0. But what eventually, if we're just focusing on numbers that are less than 4, eventually what's going to happen if we keep going down that number line less than 4? I don't know anybody's names yet. What's your name?
Steven.
Steven.
It's infinite as an infinite amount of numbers.
Well, that's okay. We can have an infinite amount of numbers in our solution. That's okay. But what happens when we take an absolute value of them as we're going down that number line? You want to try again, Steven?
Makes it positive.
Okay. Well, what does that mean?
I don't know.
I don't know. It's all right. Let's jump to the side over here. What's your name?
Callan.
Alan?
Callan.
Callan? Okay, Callan.
Eventually, as you go lower, the absolute value technically goes higher, so eventually it'll go over 4 once you go past.
Exactly. Once we go past what number precisely? -4. Once we go past -4, right? If I go -5, or if I even go -4.1, if I take the absolute value of that, is that going to be less than 4? No, -5 is, the absolute value of -5 is greater than 4. So when I'm trying to find the solution set here, it can't just be numbers that are less than 4. So we know it's definitely going to be numbers that are less than 4, but also what? We need the other side of the restriction.
Greater than -4?
You got it. And I'm going to put the word and greater than -4. So if I'm looking at the numbers that are greater than -4, but less than 4, that represents every number between -4 and +4. This would be the graph of our solution set. And if I'm between these two numbers, no matter what number I plug in for x, will this still hold true? Yeah. Is it important that I have the word and between this? Yeah. What would happen if the word was an or? If I had x is less than 4 or x is greater than -4?
Rika.
What, Rika?
Mm-hmm.
Okay, Rika.
It would be all real numbers.
You got it. So if this is 0, this is -4, this is +4. If I'm taking all the numbers that are less than 4, but also all the numbers that are greater than -4, remember, or is combining those two graphs together. Doesn't that end up being the whole solution set of the real numbers? And we just talked about that. It can't just be any real number in here. It's not going to work out. So that's why the and is so important here. So this is wrong. And when we have an and inequality, you're allowed to write it as one long compound inequality. So it would be our solution set x such that -4, you always pick the smaller number, is less than x, which is less than +4. So there's our graph and our solution set. So I'm going to put a little star here. When we have an absolute value and less than inequality, it will always be an and problem. So when you have an absolute value inequality and that inequality is a less than, the connecting word will always be and. Okay, let's switch this now. I'll let you finish copying. Okay, let's take the same exact problem, but instead of less than, let's make it greater than. X is greater than 4. So the obvious would be X has to be numbers that are bigger than 4. Obvious, right? So if I pick any number that's bigger than 4 and I plug it in, will this hold true? Yeah, absolutely. But are the numbers bigger than 4 the only solution we can have here? No, because if I plug in a -5 in for X, -5 is less than 4, but wouldn't the absolute value of -5 be greater than 4? So I need another part of this restriction. So X is greater than 4.
X is less than -4.
X is less than -4. But now we need a connecting word. Do you think it's an and or an or? What's your name in the back?
Ilya. Or.
Ilya? Yeah, this is an or. Let's talk about why it's not an and. Don't write this down because it's wrong. But if we had X is greater than 4 and X is less than -4, the graph would look like this. And what would be the solution if the graph looked like that for an and? No solution, right? And clearly there's solutions here. So we know that is definitely not an and. Let's look at the or. And I'm pretty sure for the or, it's saying it could be in this solution or it could be in this solution. So as long as it's in one of the graphs, it's making it to the final set. And I'm looking, every number that's covered in this arrow works, and every number that's covered in this arrow works. So this seems to be the fitting solution. So if we were to write this in our solution set, it would be X such that X is greater than 4, and you'd have to write the word or. If you wanted to use that union symbol, you can instead of writing the word or. X is less than -4. So that would be our solution and the graph of our solution. So writing it all linked together only works for an and scenario. For an or, it is usually separate, or it's always separate. Okay, let's do a problem. Oh, sorry. Actually, let's just sum this up for us. So we're going to say absolute value with a greater than inequality will be an or problem. So if it's less than, it's an and. If it's greater than, it's an or. So you all try this one on your own. The absolute value of 4y plus 2 is less than 10. So I want not only the solution set, but I also want the graph of the solution. So give me the solution set and the graph. In the back, could you take out your AirPods? What's your name?
Asher.
Asher? Could you take out? Yes.
always be an or.
If it's greater than, yep. Oh, but also, guys, before you decide, sorry, I should say this. Before you decide if it's an and or an or, you need to make sure the absolute value is completely by itself. So, for example, let's say I had this. -2 times the absolute value of x is greater than, I don't know, 4. So this looks like a greater than problem, right? So you would think it's an or, but you can't decide until the absolute value is by itself. So what does that mean? Divide by -2, divide by -2. So when I divide by that -2, what happens? The sign switches, so it really isn't an or, it ends up being an and. So you can't decide until the absolute value is completely by itself. Who has a solution set for me? What's your name? Pranav.
Y such that -3 is less than y is less than 2.
Perfect. And then your graph of this solution set will be -3, +2, open circle, segment between them. Anybody need to see me do this problem? Don't be shy if you do. Okay, let's step it up a little bit. So this is what I had just briefly mentioned when Pranav had, was it Pranav that asked me a question? No. Was it, what's your name? Omesh. It's when Omesh had asked me. So right now you see absolute value, you see greater than, you're thinking, okay, this is going to be an or problem. But we can't decide that. We can't decide that until we do what? Isolate our absolute value. Actually, anytime we're solving an absolute value problem, we can't even make separate equations until we solve, until we isolate the absolute value lines, whether it's an inequality or an equation. We always have to isolate the absolute value lines before we do anything to solve it. So right now, a lot of students tell me we should add these together and make it a -7. How come I'm not allowed to add these together and make it a -7? I want to say Kellen? No? Callan. Okay.
Essentially, the -2 on the outside, it's kind of like parentheses, where essentially you multiply it into the absolute value. So you can't remove this -2.
That's exactly it. Remember PEMDAS, you have to multiply before you add, and when you have a number and then absolute value or a number in parentheses, technically it means multiplication. So it's saying this -2 needs to be multiplied by the quantity of this absolute value. But we can't do that. So right now we need to isolate this. To isolate it, we need to move everything else away. So what I'm going to do is first add the -5 over. So when I go do that, we do +5, +5, and we're going to get -2 times the absolute value of x plus 3 equals -6. Now, I'm not going to add the -2 over because it's being multiplied with the absolute value. So to undo the multiplication, we're going to divide by -2. Oops, sorry, this is greater than or equal to. And when we divide by a negative number, what ends up happening? The sign switches. So now we have the absolute value of x plus 3 is greater than or equal to positive 3.
Wait, did you switch it?
Oh, sorry. I said switch, but I didn't switch. There we go. So now we need our two different inequalities. We're going to have x plus 3 is less than or equal to positive 3. And remember what we do now. I'm going to put an and because it's less than, and it's going to be x plus 3 is now greater than or equal to what? Negative 3. So not only do we flip the sign, we negate the number. So flip the sign, negate the number. And then we solve. So we're going to have x is less than or equal to 0. Is it okay that that number is 0? Yeah, absolutely, that's fine. And x is greater than or equal to negative 6. So if we're going to write this as a solution set, you always put x such that, pick the smaller number first, which is negative 6, is less than or equal to x, which is less than or equal to 0. And then our number line will be negative 6 and 0. And this time, why am I using closed circles when every other time I used open circles? Pranav?
Because it's less than or equal to.
Good. Because of the line underneath the inequalities tells us it's or equal to, so we're putting that as part of our solution set. Okay, next one. Okay, I have a lot going on. I have this compound inequality to the left, and then I have this absolute value inequality on the right, and I also have the word and connecting them, meaning in order to make it to the final round, it has to be in this solution, and it has to be in this solution. So what I'm going to do is I'm going to work on these two separately, not combined. I'm going to first find out what the solution set is for negative 7 is less than 2x minus 4, which is less than 2. And remember, when you have one compound inequality all together like this, what's the connecting word? And. So what I'm going to do is I'm going to make two different inequalities. I'm going to put and in the middle. And the first inequality, we're going to start at negative 7 and go all the way to the second inequality sign, but stop. Don't include that. So my first inequality is going to be negative 7 is less than 2x minus 4. Put the word and. And now the second inequality, I'm ignoring the negative 7 less than. I'm going to start at the 2x minus 4 is less than 2. That's the second inequality. I'm going to now solve this. So I'm going to add 4 on both sides. So we're going to have a negative 3 is less than 2x. Divide by 2. And we're going to get x, I'm actually, because I'm plotting this on a number line, I'm going to write it as a decimal. Negative 1.5 is less than x. Now let's solve this side. So plus 4 plus 4. So we're going to have 2x is less than 6 and x is less than 3. So I have negative 1.5 is less than x, and x is less than 3. I'm not going to write the solution set yet because the solution set is for my final answer. Is this my final answer? No, but what I am going to do is I am going to graph what this looks like. So 1.5 would be right over here, negative 1.5. So I have an open circle on negative 1.5, an open circle on 3, and we're right between those. All right, now I'm working my way to the other side. Everybody okay so far? Right, x is greater than negative 1.5, x is less than 3, and it's an and, so we're going together there. Right, on the other side now, it's an absolute value inequality, but it's greater than, and the absolute value lines are already by itself. So will this be an and, or will it be an or? What's your name? Tyler? Yeah. Or, very good. So I'm going to have 4x plus 1 is greater than or equal to 3, or, and now how do I get the other inequality? Flip the sign and negate it. You got it. So we're going to have 4x plus 1 is less than or equal to negative 3. We're going to solve this now. So 4x is greater than or equal to 2. X is greater than or equal to a half. Here we're going to have 4x is less than or equal to negative 4. X is less than or equal to negative 1. Okay, so this is saying x is greater than or equal to a half. So close circle over a half, go to the right. X is less than or equal to negative 1, close circle on negative 1, go to the left. Is this an acceptable answer for or? Arrows going in different directions? Absolutely. If it's in this solution, we're good. If it's in this solution, we're good. So far, we're good. But now, what do I have? I have to connect these two. So not only does it have to be in my first solution, it also has to be in the second solution. So what I'm going to do is I'm going to put the two graphs together. So I'll probably just put it right underneath the first graph. So we have a closed circle negative 1, go to the left. And then we have a half, which is right here. Closed circle on a half, go to the right. So now, in order to make it to the final graph, because it's an and connecting them, it has to be in the pink graph, but it also has to be in the green graph as well. So where are my pink and green graphs overlapping? Sam? Steven, sorry.
They're overlapping between x is less than negative 1 and greater than negative 1.5, and x is less than 3 and greater than or equal to 1.
Perfect. So right here. So it looks like we're overlapping from a half all the way to 3. So my first question is the half included in both of these? Yeah. The 3 is included in the green, but it's not included in the pink. Since it's not included in the pink, can I include it in the final solution? No. So the half is included, the 3 is not. That's perfectly okay. On this side, is the negative 1.5 included? No. Is the 1 included in both? Yeah. That's perfectly fine. So how am I going to write this? So I'm going to talk about the two different places they overlap. So it's going to be, oops, x such that, I'm going to start off with the left one. So we start off at negative 1.5. So negative 1.5 is less than or equal to, right? Because it's, oh, sorry, not equal to, just less than, because the pink one is not included, is less than x, which is less than or equal to what number? What's your name? Layla. Negative 1, perfect. But now there's a big gap in the middle, right? Between now where we first overlapped and now where we second overlap. Because there's that big gap in the middle, I can't use the word and. Because and means it would have to be in this and it would have to be in that, which isn't the case. So what connecting word do you think I have to put? Or. So it's in this solution, or it ends up being in this solution. So or, and then we're going to have negative, oh, sorry, not negative, positive a half is less than or equal to x, which is less than 3. So the two graphs overlap in this inequality, but they also overlap in this inequality. All right, last problem for today. Okay, so not an inequality, just an equation, but this is different because we have the two absolute values. What you want to do when you have two absolute values in the same equation, you want to bring them to the same side. So what I'm going to do is I'm going to bring the absolute value of x plus 4 over to the left side by subtracting it over. So now this is going to be the absolute value of 2x minus 3 minus the absolute value of x plus 4 equals, and when I subtract that absolute value of x plus 4 away, what am I left with? 0. Okay, now there's different scenarios that can happen. Do we agree that the quantity in the first absolute value and the quantity in the second absolute value can both be positive? So what we're going to do for that is we're going to show a plus plus, positive positive. They can both be positive. That's our first scenario. Our second scenario is that the absolute value of the first one is positive and the absolute value of the second one can be negative. So I'm going to do a plus minus for the second scenario. Okay. I can have the scenario where the quantity inside the first absolute value is negative and the quantity inside the second absolute value is positive. So I'm going to write a minus and a plus. And what would be the fourth scenario? What's your name? Justin. They're both negative. So both quantities inside the absolute values are negative. All right, so now what are we going to do with this? We're going to see all the different scenarios out and see what holds true. But because this is an absolute value inequality, an absolute value equation, we need to check our solutions to make sure that they work out. So the first scenario is I'm going to take the quantities inside of these and they're both going to be positive, which means I pull them out exactly as they are. So we're going to say 2x minus 3 minus, in parentheses, x plus 4 equals 0. Did I need the parentheses around x plus 4? Steven?
Yeah.
Yeah, why?
Because the negative is being multiplied to the x plus 4 in the original equation.
Yeah, we're subtracting this whole quantity. If I didn't have the parentheses around it, it would only be subtracting the x. We're subtracting that whole quantity. So I'm going to have to distribute. So when I distribute, I end up with 2x minus 3 minus x minus 4 equals 0. And now we're going to solve. So I will have x minus 7 equals 0, and x will equal 7. Just because you get an answer does not mean that answer is correct. You will not know if that answer is correct until you plug in to the original to make sure that it holds true. So I'm going back to the original, not the one I moved. So back to the original, which is 7. Which is 2 at quantity, absolute value of 2x minus 3 equals the absolute value of x plus 4. I'm now going to plug in a 7. 2 times 7 is 14 minus 3 is 11. 7 plus 4 is 11. The absolute value of 11 is 11. So are we good with 7? Yes. So this answer definitely works. We're good. Now we have to check out the other scenarios. So scenario B is saying keep the first quantity as it is, positive, but now we're negating the second quantity. Now be very careful. This minus is not negating the second quantity. This minus is just saying subtract that second quantity. So to negate that second quantity, I need the minus, but then another negative. And what happens when you have a double negative? It becomes a positive. So now we are 2x minus 3 plus x plus 4 equals 0. So we're going to have 3x plus 1 equals 0. We will get x equals negative 1/3. We need to check this. So this is going to take a little bit of work. So we're at 2 times negative 1/3 minus 3. That's the absolute value. So this is going to be negative 2/3 minus 3. Bring it up here. I'm going to make a common denominator. So it's negative 2/3 minus 9/3, which is negative 11/3. What is the absolute value of negative 11/3? Positive 11/3. On the other side, I have negative 1/3 plus 4. So again, I need to make a common denominator. So negative 1/3 plus 12/3, again, is negative 11/3. The absolute value of positive 11/3. The absolute value of positive 11/3 is still 11/3. Does the negative 1/3 work? Yes. So that's our solution. All right, now let's check out the other scenarios. So A and B. So choice C was negate the first, keep the second positive. So we're going to have the negation of parentheses 2x minus 3 minus quantity of x plus 4 equals 0. Are both parentheses necessary here? Yes, because we're distributing that negative. So we're going to distribute that negative. So we will get negative 2x plus 3 minus x minus 4. So we will get a negative 3x minus 1. And once again, we get a negative 1/3. Didn't we already get a negative 1/3? We know it works. Do I need to recheck that again? No. And then the last one will be 2 negatives. Negative, negative. So the negation of 2x minus 3 minus the negation of x plus 4 equals 0. That double negative makes a positive. So we get negative 2x plus 3 plus x plus 4. So we are at, what did I do? Okay, negative x plus 7 equals 0. X will equal 7. Didn't we already get x equals 7? And we know it works. So our two solutions are going to be x equals negative 1/3 or 7. Notice how I wrote it. X equals, I put the negative 1/3 comma 7. That's a perfect way to write it. Why are you not allowed to write it inside parentheses? So I was allowed to put the comma as long as I didn't put parentheses. Lucas? Good. A parentheses represent a coordinate, an XY value. These both represent X. Okay, we are done for today. Your homework is posted on Classroom.